Good afternoon. Welcome to this session about what's new in SQL Server Analysis Services 2016 for tabular models. Before starting, I would like to check whether you are attending the right session. This is a session about what's new. So how many of you already know and or use Analysis Services Tabular? Any version? Perfect. You are in the right place. I will not do particular introduction about analysis services. I just have one slide to recap the architecture, but we will not spend too much time on that. So what I will show you in this session is fundamentally what are the new features that have been included in this new version of analysis services from the point of view of the performance, of the data model, and of the development tools. And of course, I will try to keep some time at the end for your question, because I imagine that you will have many. My name is Marco Russo. I'm from SQL BI. I wrote several books, articles, white papers about DAX, analysis services, Power BI, Power Pivot. You can find everything on the SQLBI.com website, and also the books are published by Microsoft Press, and for a living, besides writing books, I also do consulting. So this is a quick summary of what you have in Analysis Services 2016. I split the new features in several groups. So we have new feature for data modeling, new feature for direct query, which is an interesting section. I will discuss about that later. We have especially many interesting improvement in performance, and of course, development tools and management tools. It's still a work in progress, I would say, for this part, the development tools and management tools, but we will discuss this when we will approach that part. So I will start not reading these topics. This is fundamentally a list of what we will see during the session, so I can quickly start with a few slides, and then I will try to spend more time in demos and showing you what we can do. First of all, a few notes about the architecture. As you see in the slide, Analysis Services Tabular is a server product, which is part of Microsoft SQL Server 2016. Analysis Services as a product has two different engines and two different type of models that you can create. We have the multidimensional model, which is the model that you had since Analysis Services 2005. And we have, since Analysis Services 2012, an option for another type of technologies, another technology that is called the tabular model. This technology is the same technology that runs Power Pivot and Power BI. So when you create a model in Power Pivot or Power BI, you are using the same engine that we have in Analysis Services. So why using Analysis Services? Fundamentally because you have more control over deployment, security, how you process data, how you organize the refresh, and you can manage larger models. This is the main difference between Analysis Services and Power BI, I would say. Besides the fact that you can run your server on-prem. Today, Analysis Services is on-premises product. We still don't have a cloud version, but I hope that one day we will see something new on that side. If you know the architecture of Analysis Services Tabular 2012-2014, in this slide you will notice one difference. In this new version, we have separation of the engine in two parts, the formula engine and storage engine. Nothing really new if you have your data stored in memory. However, if you use direct query, which is a technique in which you convert a DAX or MDX query directly into a SQL query, and not only for SQL Server, but for many other databases we will see, we still use the formula engine in Analysis Services. This is a difference between the previous architecture. I will come back on this concept later, but fundamentally now we have a better compatibility between the DAX functions that you have in the DAX language and direct query. So you no longer have certain limitations because fundamentally direct query become just another storage engine. We can have the internal VertiPack in-memory storage engine, and we have direct query. We will come back on this later when we will talk about direct query. Usually, you use the VertiPack engine. The VertiPack engine is the engine that stores data in memory. How it works internally is completely transparent to you, and if you use DAX or MDX as a query language, Excel generates queries in MDX, Power BI generates queries in DAX, but this is completely transparent to you. You can use both engines, and when you use the VertiPack engine, all the data are stored in memory, so fundamentally you have a periodic refresh between your relational data source and the in-memory engine, and you always query this copy of the data that you have in memory. So this is the general architecture of analysis services, and as I explained, there is a difference because in the past, the formula engine only worked for the in-memory mode. Now the formula engine also works for direct query as a layer on top of the direct query storage engine. The new engine has a number of new functions that you can use in DAX. These are the same functions that you have in Excel 2016 and in Power BI. So if you are developing a model in Power BI these days or in Excel 2016, you can use the same functions. And fundamentally, you have the ability to improve the way you express your measures and your queries. I will not go too much in detail into this part. There are articles, there are many topics, and we will spend too much time. I think that the most important part is that there are a number of new table functions in DAX that improves the performance of Power BI in particular. Power BI takes advantage of these new functions, and Power BI, when it connects to Analysis Services 2012, 2014, or 2016, generates DAX queries in a different way. So if you want to get the best performance, you have to connect Power BI in live mode to Analysis Services 2016. Because if you connect it to 2012, 2014, you will notice that the performance will be not the same, especially when you have many objects in the same report. Another function that I will show you in the demo, here we go a little bit more in detail, is that of the bidirectional filters. Bidirectional filters are an important new feature that is available at the data model level. You have exactly the same feature in Power BI. You do not have this feature in Excel 2016. So the engine is the same, but the data model cannot, in Excel, cannot have this ability to describe in the data model the bidirectional filter. There are important considerations about this feature, but I will discuss when I will show you the demo in a moment. Always from the point of view of the data model, another feature that has been introduced in Analysis Services 2016 is the one of calculated tables. Again, this feature exists in Power BI. So there is nothing new if you already know Power BI, but for Analysis Services Tabular, this is an interesting feature that can solve certain particular use cases. You may think why I should use a calculated table. Fundamentally, we always say that you should prepare data in advance, so you should not use analysis services as a tool to manipulate data, as an ETL tool. However, sometimes you may have a scenario where preparing data, aggregating data, creating a snapshot of data at a certain level may be much faster performed in DAX instead of performed in SQL, for example. And this is exactly one of the examples that I will show you in a moment. So if I want to create a snapshot table in order to improve the performance of certain queries, I could create this table using a calculated table in a much smaller time. So the process time will be reduced because of this feature. And the example will show how this equivalent query in SQL that will run in around 50 seconds on this machine can run much faster if executed in this equivalent DAX query. So this will will be just your reference in the slides, but now I will spend some time looking at how these features work. So let me start with, I can close this one. Let me start showing you the new Visual Studio. First of all, you have to, can I disable this? Quiet hours. Don't show up icons, maybe this one. So if you use Analysis Services 2016, you should use Visual Studio 2015. And we have the management and development tools that automatically install the shell of Visual Studio or can embed this environment in an existing installation of Visual Studio. I already prepared a number of projects of example, and I will start from this project to show you some of the features that we illustrated in the slides. And the first one is the one of the bidirectional filter. So let me start to describe you this model. We have a very simple data model where we have date, sales, and product. And as you see, when you define a relationship, you can have this bidirectional, these two arrows that describes a bidirectional filter, and you can change the propagation of the filter using this dialog box. By default, when you create a relationship, you have this, you have this way of working. Why this changed the code, okay. You have this filter propagation. The default propagation is always one-to-many. So in a relationship, if you apply a filter on the one side of the relationship, the filter propagates, is propagated to the many side of the relationship, but not the contrary. What is the consequence of that? So by default, if I have this data model and I create a report, for example, in Power BI, and I already prepared this here, when I query this data model, if I have a measure that do a distinct count on products, when I try to filter by year, I do not have any effect. Let me explain you what I'm doing. In this case, I have in the sales table here, 1 second, I have this definition of products. Let me highlight this. So products is just the distinct count of the product key column in the product table, and colors is the distinct count of the color column of the product table. Now, my idea is I would like to count how many unique colors, how many unique products, how many unique colors I sold in each month of the past 2 or 3 years. And unfortunately, when I filter the year here, I do not automatically filter the product. So the filter applied on a year in my report filters sales, but do not filter product. We have the ability to use particular syntaxes in DAX to enable this propagation also in 2012, 2014. But if you read a few articles that I also wrote in the past, sometimes this is not for free. You might have to pay a price, especially when you don't want to apply this propagation automatically every time for any calculation. I also have another measure here, which is the distinct count of the product key column in the sales table. Now, in reality, this measure works because I'm counting the unique number of values in the product key column in the sales table, and this is affected by the filter applied to the year. In fact, if you see, the numbers are different here in this column for 2007, 2008, every month. But the number of products is always the same because it is not filtered. This table is not filtered. As soon as I change my relationship here and I apply a bidirectional filter here, I just have to refresh the query here, and you see that now the two numbers here are the same. Why? Because I'm doing the distinct count of the product key in one table, sales, and the distinct count of the product key in the product table. So at this point, you may be confused, but what is interesting is the colors column. As you see, we have a number of unique products here sold in April 2007, and the number of unique colors sold in April or February is 13. the fact that the months are not sorted correctly is because I applied a sort order over colors. And as you see, we have a different number here because this is applied to just that column in the products table. This small feature is extremely important to obtain certain patterns without writing too much DAX code. And from a performance point of view, you obtain very, very good performance because you pay the price for the propagation of the filter only when there is a filter active and not also in calculation when this filter is not active at all. The other feature that I wanted to show you is that of the calculated table. As you see in this model, we have a number of tables that have been imported from an external data source. So we have the table customer, the table date, the table sales. But this table snapshot customer class has been imported using a view that corresponds to a SQL query that I can show you in SQL Server Management Studio here. I prepared it before because in this way we have time to show many different things. Before starting the session, I ran this query, and as you see, this query produced a number of rows here. I think now it is not visible, but it is around 17,000 rows, and this query executed in 49 seconds. Unfortunately, I lost the connection, so I should execute this again, but the number was 49 seconds. If I look at my model, I go back in Visual Studio now, if I find Visual Studio. Let me see. Come on. Oh. Close Visual Studio. Oh. For some reason, Visual Studio didn't like my demo. So now I open again the project. Give me 1 second. And I will show you that the very same table is present in two different parts of the project. One is imported from SQL, and the other is generated by using DAX query that is automatically executed and updated every time I will refresh my data model. Hopefully, this will arrive at a certain time. And if not, we will continue. Okay, it's coming. It's not very, very fast. Okay. So the idea is that the calculated table can be useful when I want to lower the time to refresh tables that can be obtained by working by querying other tables. Why this could be important? Because I applied the same pattern in Analysis Services Tabular 2012-2014 in the past, but I had to query my Analysis Services engine through a linked server in SQL. So basically, I had to run the query in DAX from a SQL Server linked server and then get the data from SQL. It was a useless way to copy the data around. The query was fast, but the time to copy the data, moving data through SQL Server, was very slow. So by using the calculated table, you only pay the price for actually executing the query, because then the result of the query is compressed by the Tabular engine, but you don't have to move data between two different processes. So in this case, this is the query that generated the number of rows that you see here, 17,000 and something, and the same number of rows and the same content was obtained by this SQL query. So the idea is that when I refresh the data model, this query in DAX is automatically executed, and the content of this table is always synchronized with the rest of the database. You don't have to worry about that. You do not have partitions on this table, of course, so this could be a limit, but usually I have seen that the execution and the compression of this table is very, very quick. So if you are not creating 100 million of rows or more, but you're creating a few 100,000 or a few 10,000 of rows, the performance usually are very, very good. From a user interface point of view, how it works. You go here, create a new table, you click here, and you can write any syntax in DAX, why this is showing this in this way, any syntax in DAX where you can execute any DAX expression returning a table. So for example, if I write summarize of customer, and I will write customer city, for example, and customer country, just to show you an example. I run this query, I obtain the result of this query here, and this result is immediately stored and compressed like any other table of the data model. And of course, you can create relationships. It's a table like any other table. As I said, the number of scenarios where this is really important could be limited. In reality, is not so frequent, but I have seen that in complex projects, when the time to refresh the model has to be reduced, this could be very important. You have already noticed that I had a better DAX editor, not perfect, but better than the past. In general, SQL Server Data Tools now has many new features, and there is a new format of the data model that we can use. We will see this in a moment when we will see the internal language. Since June, when the first version of SQL Server Data Tools has been released for Analysis Service 2016, these tools have been updated. There is an update every month, usually, and two important features have been introduced. One is the Tabular Model Explorer, and the other is the Integrated Workspace Mode. I will show you these features in a moment. One thing that I mentioned is that there is a new language used to describe the data model. If you know, in Analysis Series 2020-2014, the model was described using XML, and fundamentally reusing the same XML used by multidimensional, trying to embed and to map the tabular object model into the former dimensions and measure groups that we had. And the result was a very confusing source code that was very hard to manipulate or just to compare between two different versions. Now we have a JSON format that corresponds and then matches one-to-one the tabular object model. So even when you have two different versions, if you are using any tool to control the versions and to manage the versions, you can compare two different versions with a text editor, and it is very easy to analyze what changed between a version and another. And also, this enables also working in a group, because merging the differences made by different people on the same data model is relatively easier. We will see an example of that in a moment. Another feature that has been introduced in the data model, and so also in the new development tool, is that of the display folders. This was a feature that was already available if you used the Bits Helper in Analysis Services 2012-2014, but that feature in Bits Helper used a particular feature that was designed for multidimensional. So one issue is that if you use this feature in the past with Bits Helper, when you will migrate your model to 2016, you will lose the settings that you made to the display folders, and you have to define them again. So unfortunately, the internal format is different, and the migration is not supported for that. Display folders are the same features that, display folders are available to clients like Excel and Power BI. I will show you in a moment. At the moment, Power BI cannot define this natively, so you can use Power BI as a client displaying the display folders, but you cannot create display folders in a project defined natively in Power BI. So let's start with the new development experience. And just a second. There is one other feature that was in the slide that I didn't mention, that is the one of the integrated workspace. If you create a new project in Analysis Services Tabular, for example, I create a new project here, Analysis Services Tabular, and this is the dialog box that you have now. These are the choices that you have if you install the latest release of SQL Server Data Tools, the one released in September. Usually, you had to define a workspace server. What is a workspace server? It's an instance of Analysis Services where you have a copy of the tabular model when you have Visual Studio open. So actually, Visual Studio keep a current version in Analysis Services and always update the data there. But this forced you to have an instance of analysis services just to use Visual Studio for development. Now you are able to set integrated workspace, which means that you can create a new project using a special instance of analysis services that is deployed with SQL Server Data Tools and installed as a local user. So you do not have a service running analysis services, just like Power BI. So if I create a new project now, and as you see, if I try to create the project in an older version, let me see, it works, okay. Sorry? I don't understand the question.
No, you said it's like Power BI desktop, not
Power BI desktop.
asking about is it the same as Power Pivot? It's not. Power Pivot doesn't have a separate server.
Okay, I repeat the question. Okay, wait a second. Okay, I repeat the question. In this moment, I'm creating a new project in Visual Studio. And the workspace server is always a separate instance of analysis services. In the past, this instance had to be a service installed as a workspace server. Now I can use an instance of analysis services that run on the fly, that is automatically executed by Visual Studio. I don't have to install a service for that. Power BI Desktop uses the same identical technology. Power Pivot does not use this technology and has a DLL that embeds the engine in process. The advantage of this approach is that the service that runs the engine is a separate process, so you may have a 64-bit server even if your client is running at 32-bit. When you use Excel, if you're running Excel in 32-bit mode, also the server runs in 32-bit. And this is usually the big limit in Excel for the memory that you might use. Whereas using this technology, even if you install Power BI Desktop in 32-bit mode, you always run the service in 64-bit mode. So the backend is always 64-bit. I answered the question? Okay. So what's happened now? I created a new project. I import some data in this new project. So I select, for example, a SQL Server. I write the demo here. I select a database. I select a few tables here. That what I'm selecting now is not really very important. Just let me get a few sales product should be enough, and finish. So now I'm importing a few rows from a couple of tables in a database. And what is interesting at this point is that if I look at SQL Server, at Windows Task Manager, you see that there are a few instances of analysis services running with my username, Marco. Those instances are services installed on my machine. I have, all the versions of analysis services, tabular and multidimensional, but I also have one instance for every model that I open in Visual Studio at this moment. So these are instances that are automatically executed by Visual Studio and that host my data model. Now, my data model is running there. So the advantage of this approach, I don't have to install SQL Server. I just had to download the SQL Server Data Tools. I install SQL Server Data Tools, and I can already use SQL Server Data Tools because the engine is part of the SQL Server Data Tools now. And so also the version is automatically updated every time you install a new version. At this point, so this is an advantage for the developers. I want to show you that the model that I created is still a model in XML. What does it mean? When I created the new project, I had to choose the compatibility version. You can choose the compatibility version 11.00, 11.03, 12.00. I chose the old one, 11.03 or 11.00, which is the XML one. The same used in Analysis Series 2012-2014, which means that you can use this, and you can deploy. You can use this version of Visual Studio, and you can deploy on an old version of Analysis Services. So you can use the new version of Visual Studio even to manage the development for your legacy version of Analysis Services. When you make a decision of getting your existing project and you want to upgrade this model to the new compatibility version Of course, if you create a new one from scratch in this way, no problem. But as you see, the compatibility level is something that you can change at the project level. If I do the change, moving a model to the new model, 1200, there is a warning that explains me, be careful, you cannot undo this operation. Once you move to the new model, you cannot go back. So it's a one-way only operation. What's happened? My model is identical, nothing changing, apparently. But if I look at the code, now I have the new data model and the new language. As you see, this is the new format, is a JSON format, and we have objects that corresponds in a one-to-one way to our entities. For example, we have an array of tables. For every table, we have an array of columns, partitions, annotations, which are internal information for Visual Studio. This format is not perfect, I would say, because sometimes you will find something like that. But as you see, the presence of some XML code is usually limited to a few annotations. These are information saved by Visual Studio to keep some internal information, internal property. But if you remove all the annotations, the model still works. The model, for analysis services, what is important is what you have here in the JSON part. Now, if you're not a developer, you may not care about this, but the interesting part is that this file, this is a text file that it is much easier to manage and also to read. If something goes wrong, or if you want to compare two versions, it is much easier to take a look at this file instead of analyzing different things, the differences in XML. Okay, display folders is the other topic. So let me show you in another project. I already created something in advance because otherwise I will not have time to show you everything. In this model, I have a number of tables. I show you quickly what I have. So this is a classical model where we have sales, store, product, promotion, date, and currency. Nothing particular special here. But as you see, the product table has a number of attributes. I may want to organize these attributes in a way that it is much easier to use. And the final result that I want to obtain is something like this. Look at the product table here. As you see, a few attributes have been included in a folder info, other in pricing. Here I have a few attributes. Here I have a few attributes. And within stock, I also have volume. You might also have measures and not only columns included in a display folder. So display folder is a way to create a hierarchical structure of information within a table for your measures and columns. How you define that? In Visual Studio, you have a property that you can modify for each column and for each measure, which is called display folder. For example, here, you can see that the display folder is info. And if you remember, a few attributes were included in a display folder called info in my user interface in Power BI. Power BI has a UI that uses the information of display folders, and also Excel can use the same information. If you want to include a folder within another folder, you can use this syntax. So name of the folder first level, / folder second level, and so on. So you do not have a way to see the hierarchies of the folder in Visual Studio. You have to remember what you're doing, but at the end, the result is something that can work. Okay. Moving forward, we have another interesting feature that is especially important for those companies that have different languages, multinational companies that want to provide the user interface of the semantic model in different languages. The new version of Analysis Services supports translations. What you can translate is actually only the metadata. So you can translate the name of the tables, the name of the attributes, the name of the columns, the name of the folders, the name of the measures. You cannot translate the content. You cannot translate the internal name of a product that has to be displayed in different names. So you can display, you can translate the column name. So instead of product, you can call in Italian, for example, we say prodotto. But you cannot translate the names of the products. And so this is something that you can do in multidimensional. We still don't have an equivalent feature in Tabular. That said, how it works. We can see in the demo the technique. So I can go back to my demo machine, and I can show you this example. So the idea is that every project is a single file in JSON, which also includes the translations. For example, this is a project that already has translations between English and Italian. Italian is the second language that is supported in this model, but I could create French, German, and so on. So if I look at, I think, yes, here, you see that in a certain part of the model here, we have this. We have a particular part of the JSON file which contains the translation between the original names and the equivalent names in Italian. However, this part, this translation, is not immediately visible in other parts of Visual Studio. The design choice made by Microsoft is that if you want to create translations, probably is not the developer who is creating the model that knows how to translate the names. So what you do in order to create a translation is the following. You have, in the model menu here, you have a translations menu here, which provides two different items: manage translations and import translations. So the first step is to create a file that contains potential translations of names in 1, 2, or more languages. For example, I select the Italian, but I can also select the French and so on. The first time you create an empty file. You create a file that just contains the list of the names that have to be translated. So for example, if I export these Italian names, or let me create another language. For example, let me create something in French. French, France, this one. So I can do this, and I want to export, no. I want to export the French language, this one. And so ignite French. So the file that I'm going to create is a JSON file called French that I will be able to open with any text editor. For example, I can right-click and open with, for example, Notepad++. Okay? This is just a text editor that shows the content, and as you see, these are the names that are available for the translation. The idea is that I will provide this file to someone who is able to translate. He will change all the names and will send me this file back, this JSON file, and I will import the translation in my data model. Now, I don't know what you think, but I think that I can provide this file to someone who translates from one language to another, but it will be very dangerous because any change to the square brackets, columns, and double quotes will be very dangerous. So in order to avoid this problem, there is a tool that one of the PMs of analysis services created initially, and we contributed in improving a little bit. So the analysis services tabular translator, if you go in this website, sqlbi.com/tools, there are a number of tools that could be useful for analysis services developer, and I'm going to show you the tabular translator. So I downloaded this tool that is also available with the source code, is an open source tool, and I have this tool here, tabular translator. So if I open this tool here, I had to open, I don't have it open. So I open this tool, and I open the file that I have here. I could open the French file or the Italian one. I open the Italian one because I already have the translations. This is what I see. I see the original language in a set of columns and the translated version in another. This is a file where I already created the translations in Italian. In a single file, you might have many languages, not just one. And so you can provide this small executable and the JSON file and say, OK, write the translation, save the file, send me the file. That's the idea. Once I have the translated file, I simply go in Visual Studio, and I import here the translations. So import translations will read the content of the JSON file that contains the translated names and will import the translations into my data model. When I do this operation, I can choose what to do if there are overlapping names. Should I overwrite or not? Should I create a backup of the previous translation? And some other check of this type. So this is the idea behind the translations feature in Analysis Services 2016. Another interesting feature of Analysis Services 2016 is direct query. How many of you tried the direct query in 2012 or 2014? How many of you use today direct query in 2012, 2014? OK, for the record, nobody has raised the hand. Now, the reason is simple. In 2012, 2014, the performance were too bad. So bad that cannot be used even with small models. And the reason was that any expression, any query, had to be translated into a single SQL query, which in theory is interesting as an idea because you have a real-time system in this way. But the problem is that the DAX has a number of high-level concepts that were very hard to be translated in SQL in an efficient way. So there were a lot of limitations in the DAX functions that you were able to use in direct query, and direct query was supported only for DAX queries and not for MDX. What is the consequence? A pivot table in Excel generates queries in MDX, so you were not able to use Excel as a client for a direct query model. So in Analysis Services 2016, all these limitations have been removed. You can use the full spectrum of DAX features that you have, and you can use MDX as a language. Moreover, also the security roles are supported, something that was not possible, not available in the previous version. In the previous version, if you enable direct query, you would have lost the security features, the security roles. So this makes a big difference. And another big difference is that in the previous version, only Microsoft SQL Server was supported. Today, we have a support for all the Microsoft databases like Azure SQL Server since 2005, Azure Data Warehouse, and so on. There is support for Oracle and Teradata, and the architecture makes it easy to extend this support to other databases. So I expect something new to happen. Why? Because now the architecture changed completely the approach. When you run a query, the query is interpreted by the engine, and only a reduced number of queries is sent to SQL Server or to relational database to retrieve data, but not to solve the entire query. So part of the query is still solved by Analysis Services. As any decision, there are pros and cons. And I want to show you how this works, showing you what is the SQL code generated so you can get an idea about how this will work. So let me go to the demo, and let me show you what we can do with this. First of all, let's start with the development environment. From a development environment point of view, you can decide that a particular data model is enabled for direct query. How do you do that? Easy. At the model level here, there is a property, direct query mode, and you set this property to on. Once the property is set to on, you no longer see the preview of data in Analysis Services. In reality, you can still create particular partitions that are called sample partitions, so that you can load the data in Visual Studio, and you can load the small set of rows, so that you can still see a preview of the data. But otherwise, you no longer have the preview of the data in Visual Studio. If you don't create these special partitions, you don't have this visualization. In reality, however, the choice between direct query is something that you may want to change, not in Visual Studio, but once you deployed the database. How it works. If you go in SQL Server Management Studio, and you connect it to analysis services, and you go in the properties of a database, the same property can be changed at the model level here. So I could switch between default mode, import, or direct query at the model level after the deployment. Of course, if you switch from import means import the data in memory. From import to direct query means that from that moment, any request made to this database will be converted into query to SQL. If you switch from direct query to import, you have to refresh the model, because otherwise you have no data, because when you do the switch, you lose the existing data in memory. Now, in this case, I already have my model in direct query, and I want to show you what happens from a client point of view. So remember, the database is called Contoso Direct Query. If I go in Excel, I created this pivot table. This pivot table is simply a pivot table that has 3 measures here: cost, margin, sales amount. I have a number of, I put here only year and month. And as you see, when I click, it's not so quick, but it's not so bad as it was before. Just for the records, I'm using a database that has 12 million rows, and not just 60,000 like it was used in AdventureWorks. You can notice when I click on a new measure, the performance still, I have to wait a little bit, but at the end, I see the data coming. The interesting part is that when I use Power BI, the performance are much better. And I want to show you in a few demos what is happening behind the cover. The pivot table that I've shown you now, this one, generates an MDX query. I have a small extension here that shows me, as you see, the MDX code for this pivot table, and I can copy and paste this code into SQL Server Management Studio, or in this case, I'm using DAX Studio, which is another tool that is in the tools that you have seen in SQL BI, that helps me understanding what is going on. I want to warn you, the version that you are seeing today is a version that we still didn't release. There is still some bug that we have to release, but I'm using this version because it also provides me the information about the direct query that the current version that we published do not provide. So if I select this MDX query and I run this query after I enabled the profiling of the query, I will capture the SQL code that is sent to SQL Server. So when I run this query, which is the same query generated by Excel, same thing, I can see here in the timings how much time this query required to run, and all the SQL queries that have been sent to SQL Server in this case. So here we see what happened. As you see, there are joins, there are a number of queries generated by this pivot table. And you might wonder why I had to run 11 SQL queries just to create a simple pivot table. The reason is that if you look at this pivot table does not have a single granularity. There are cells at the month level, cells at the year level, cells at the grand total level. Every granularity corresponds to at least one different SQL query. Why? Because the engine now manages this approach in a different way. When you had to create a single SQL query for that, it was a nightmare. The SQL code was really a nightmare. Now the queries, yes, there are more queries, but are simpler. But this is not the best condition of working. I have to say that if you use MDX, what you obtain is not bad, but is not the optimal solution. As you see, every query run in timing between 20 and 200 milliseconds. So the total duration of this query, from the end user point of view, the end user waited for something more than 1 second. But the problem is that we had to run a number of SQL queries. Now, if I do the same, if I create a very similar query in DAX, and DAX is the language used by Power BI, look at what happened. I select this query, and I run this query. And the result is a single SQL query that runs in around 250 milliseconds. So we have an engine that is improved a lot, but is particularly the best improvements has been made when you use DAX, and when you use a particular syntax in DAX, that is the syntax generated by Power BI. The function that I'm using now, summarize columns, is a function that is one of the new functions in DAX. So many improvements have been made in the existing functions, in the existing query plan, in the existing MDX, but if you want to get the best out of Analysis Services 2016, consider using Power BI as a client, because Power BI generates the more performant DAX code for direct query too. Okay, and so the last point is just about the performance. We have a number of improvements in DAX that affects also the existing code. So as you will see in the last slide, to me is a no-brainer. Any version, any deployed database that you have in Analysis Services 2012-2014 should be upgraded to 2016, because you will see a huge performance benefit no matter what is the client you use. The number of improvements that have been made have a particular impact. For example, the second one, the strict evaluation of if switch, has a particular impact for any Excel pivot table. You will see the pivot tables run faster just because of that single improvement in performance, but there are many others. I will not list all those because many of those are not so important from a technical point of view if you just want to see the result. But the idea that these new features that are grouped in the concept of super DAX are the features that provide better performance for the existing code and provides new syntaxes like the variables, like the summarized columns that you have seen before, that also helps the engine to generate a much better query plan. I will show you an example, but the idea is that any existing code gets benefit from that. Another important improvement is for the processing. In 2012-2014, if you have a large table, even if you have many partitions, you can process only one partition at a time. In the new version of Analysis Services, if you have multiple partitions, the partitions can be processed in parallel. And by the way, by default, everything is processed in parallel, and sometimes this is a problem, because now we have the opposite problem. If everything is processed in parallel, maybe we don't have enough memory, because every partition requires memory to load data uncompressed, space to compress the data, and so on. So this feature is very important if you have large tables and you want to improve the processing time, provided that you have a fast enough server with enough memory. And this improvement is also available for models that run in the 1103 mode. So even if you do not upgrade your model to the new version, to the new compatibility version, you get all the performance benefits, included the parallel partition processing if you need it. The demo that I prepared for that is the following. I have an example here, which shows you, this is an example written in DAX, but this code, this part of the code in particular, corresponds to a possible measure that you can create in a model, also for Excel. This measure in particular calculates how many orders you have open in a certain day. This is the AdventureWorks database. I have exactly the same database. This is just a database that I I created a backup in 2012, and I restored the same backup in 2016. No changes, no process, nothing. It is just the new engine. The first connection that we try here is Analysis Services 2012. So I'm connected to Analysis Services 2012 in this moment. I select this query, and I run this query. When I run this query, what I can see is the execution time of this query. Then I can see the performance and other things, but what I'm interested to see is just this number. This query ran in 1.5 seconds, more or less. Okay, this is the last execution. And this query just provides me a number. So the result of this query is a number that says, okay, the number of open orders is this number. Open orders in a particular date. Okay. Now, sorry, I have to fix. I'm measuring the time required to count the number of open orders for all the days that I have in my data model. So in order to avoid the materialization of the result that would require too much time, I generated internally a list of 2,000 days, each one with a number that is the number of open orders. But this is executed internally. I do not show the result because providing the result on video will require too long. Remember, it was 1.5 seconds. Now I just change the connection, and I use Analysis Services 2016. So the only thing that I'm changing is the connection string. As I said, I previously restored the database without doing any change, without even reprocessing the database, and I run this query again. Now, this query produces the same result, but the time is 11 milliseconds. So you can imagine that, okay, this is a particular extreme condition, but I can obtain sometime 2 orders of magnitude of improvement. This query is 100 times faster. I'm not always so lucky, but it's easy to see huge performance improvements, especially on those queries that in pivot tables in Excel were particularly slow. Okay. So in terms of management tools, there are a few other improvements that have been applied to SQL Server Management Studio in particular. SQL Server Management Studio has a different scripting for the new models. So if you create and deploy a model in the compatibility level 12.0.0, then also the scripting that are generated to process a partition, to process a database are much simpler, are JSON files that are very easy to change if you want to change them manually. We also have a tool, DPCC, that checks the consistency of a database, and this is available for both 11.0.3 and 12.0.0 compatibility level versions. And finally, we have extended events for analysis services. In reality, I would like to highlight that the SQL Server Profiler has not been deprecated for analysis services so far. It is still the primary tool provided by Microsoft if you want to analyze what is going on analysis services. However, if you want to use extended events, they are available. All the Profiler events are also available, are extended events, plus a number of low-level events that, in my opinion, will be hardly useful for you, are more interesting for the Microsoft developers to analyze their code. So, recap. My personal suggestion is upgrade to Analysis Services 2016 as soon as possible, even if you just use the existing compatibility level, because for some reason you don't want to upgrade to the model 12.0.0. And one of the reasons is that, for example, if you upgraded to the new compatibility level, if you use the certain features available in Bits Helper, you may not have an equivalent feature in the new compatibility level. So drill-through customization and translations are not available. In reality, translations are available, but you have to write the translations in the new model. So you have to be careful extracting the translation and converting it to the new model. There is no tool to do the migration, whereas for the drill-through, we have to wait. Then Microsoft will provide an equivalent feature in the new model. Once you upgrade, you cannot go back. So keep a backup of the existing model before doing the upgrade, and in this way, you can revert back if you realize that the client, for some reason, is not ready to manage the new compatibility model. Once you have the new compatibility model, you can use features that are only available in the model 12.0.0. Calculated tables and bidirectional filters are the two features, also display folders, are the features that are available only in the new data model. For what concerns the new DAX, you can already use the new DAX functions also in the 11.0.3 compatibility level. So you can upgrade to 2016, and you can use the new DAX function without upgrading the data model. And so you can keep your bits helper if you want. OK, so at this time, I think we have time for your questions. I'm just proceeding with a number of links, but I'm open to your questions now. There are also microphones, so if you can speak at the microphone, so it is easier to keep the recording. Thanks.
So if you upgrade to the latest 2016, is there something on the client machines and Excel or whatever that it needs to be able to connect to it, like the native client or something like that upgraded, or will it just work?
There are no particular problems. In Analysis Service 2016, there is a new version of the client, of the OLEDB for all-up client, but in reality, any existing client is still able to connect to the new analysis services. Other questions there? Processing. OK, this is an interesting question. I repeat the question. If I have scripts created for 2012, 2014, do they work in 2016? And the answer is, as soon as you keep the compatibility level 11.0.3, yes. As soon as you migrate to the new compatibility level, all your scripts have to be upgraded with the new object model and with the new tools. So even if you use PowerShell or you use the XMLA script, they have to be rewritten in the new model. It's not a big deal. Actually, the new model is easier, but consider that in your migration plan. Other questions?
When is your release date? New book?
Oh, the question is about my new book. I'm writing a new book about Analysis Services 2016. I hope within December. Microsoft Press has some delay in the editing process. I hope this will not impact too much. We are very close to finish writing the chapters. We are 80%, 85% of the content ready. But my concern is about the editing process. I hope that December will be good enough. Another question?
Yes. If I'm working in the integrated workspace, are there any limitations? Like, can I still do like analyze in Excel and other things like that?
OK. The question is, I explain. When you use the integrated workspace, in reality, you have analysis services open. When you click on Analyze in Excel, so the button that opens Excel, it works. The difference is that if you save the file that you create in Excel or in Power BI, you can also use Power BI. The only issue is that you have to know where you want to connect. Now, if you are using the integrated workspace, you have analysis services open on a TCP/IP port that you don't know. If you're using Power BI, we created a feature in DAX Studio that recognizes this port. We don't have an equivalent feature today for doing the same for Visual Studio, and this is a good idea. We should implement this in DAX Studio so that you can connect to the integrated workspace in DAX Studio. As soon as you keep Visual Studio open, that instance is available like any other instances. Problem is that you have to figure out how to recognize the TCP/IP port that is used. Probably, however, it is visible in the properties of the project. So I think that in the properties of the project, you have this number. So probably it's not so hard. Otherwise, you will see the connection string of Excel, because when you click on Excel, the connection file has this number. Problem is that if you save the file, you close everything, you open this again tomorrow, the port could be different and the file no longer works. But if you fix the connection string, it works. Okay? Question?
Yeah, I tried it last week and it works. Open Excel.
Okay. He tried and it works. Thanks. Thanks. Other questions?
Is there anything that facilitates default members more easily?
Okay, the question is about default member, and the question is there something that facilitates the default member? And the answer is actually no. And the problem is that is not something easy to solve, because the default member exists in MDX. The default member as a concept does not exist in DAX. Now, if they implement this, in my opinion, they should also provide some technique to provide this concept at the DAX level, which is not something, I think that they could add some metadata that works in MDX and not in DAX. This could be possible in theory, but in practice, I've never seen that. Sorry. You had to go in the Microsoft booth, where is business intelligence, there is some PM, and push them for this feature. Okay, good. Other questions? No questions? It's time to go. Thank you very, very much. If you have any other questions, marco@sqlbi.com. Thanks.